Here the other important aspects are also equally important to understand. What does it mean? So let's look at it one by one to understand the importance of it. The blast rating is nothing but it's a blast rating of the bulkhead. When we say blast rating, this particular study is being conducted by the technical safety department. When they conduct a study, they analyze that there is a living quarter over here where people are going to stay, and there is a process platform is over there where you are injecting an oil over there. So, or removing the oil from the well. Just imagine that during this process, suppose a blast happens, then what will be the impact on the accommodation walls where the people are staying? Not only accommodation, it has to calculate the impact on the overall surrounding areas also, how it gets impacted. As you might have seen in movies, a blast happens, you will start that everyone is flying around and is being thrown at the large distance. It means that when the blast happens, there is a huge amount of compressed sound wave get generated. And when the sound waves get generated, it gets converted into the pressure in form of a pressure. So the pressure gets created in the air, through that the people gets thrown away. So when the blast happens, similar impact may take place over the accommodation and people will get impacted. So when the study is concluded and when technical department says or technical safety department says that due to wall there is a danger to accommodation, in that case wherever there are the openings of either fresh air or there is exhaust, it is recommended to provide the blast rated walls or blast rated dampers. If you Google it out, you will understand what I mean. It's a mechanical damper which is blast rated, and we need to give the blast rating to the equipment manufacturer. There are very few equipment manufacturers, or there will be few damper manufacturers over there who produce the blast rated dampers. Normally the length of those dampers is almost 1 meter, so that they can mount all the arrangements, and there's a spring over there which can sense the sound pressure and it closes automatically after achieving that pressure. And this is what the dampers are made up of. So this is what the blast rating, and I'm going to cover it much into detail in the later section how it looks around. Then the workplace sound level limit. In accommodation also, if the person is tired and he's going to come and sleep, definitely he would like to sleep in a proper manner. He doesn't want to have a very noisy sound around his cabins because he's already tired. So every standard, if you see, there is a certain level of noise level which has already been stated. Say for example, North-South, that is North Sea standard, the sound level is specified at 35 dBA, which is very stringent. So they frequently use the sound attenuators everywhere. For the other applications, somewhere in 45 is there, somewhere 55 is there. So it varies from standard to standard which we are following. So this is what the workplace sound limit is, also very important aspect while designing the HVAC system. And we need to follow whatever is mentioned in standard. Then it goes to noise and vibration consultant and he verifies whether the sound attenuator is needed. If needed, then which location it's needed, and this also report we are going to cover in subsequent session. Yes, I'm going to tell you about that report also, how it looks around. Then let's come to the corrosion resistance. What is corrosion resistance? Is nothing but it is a material selection which we need to do for the offshore. This we have already covered briefly in the previous chapters, that since the atmosphere within the sea or within it's very salty, so it affects the material selection also. So as far as possible, the critical equipment which are mounted outdoor, as far as possible, it should be either marine painted and tested for a long time, or at least for 300 hours continuous salt bath it should be given or tested for it, marine painted, or it should be a stainless steel one. Now let's come to the static electricity discharge. This part is very important because as the relative humidity in the surface drops below 30%, the static electricity gets generated over the surface of the equipment. You might have seen that in this harsh winter, if you're gone, and if you are touching any metallic object, you will get a static electricity current. The reason is that static electricity gets deposited in the extreme dry environment, and that can play a havoc if not been done the earthing properly. So static electricity discharge is also very important factor while designing the system. Wind direction plays a major role. As you know, being an offshore or being into the sea, the wind velocity is very high as compared to the land. And as you venture inside the sea, you need to check the wind direction. And ships we cannot control where the inlet and outlet of the fan we should keep. So we normally keep the static pressure a bit high than the required to cope up with the wind pressure. But for offshore we can plan. For offshore sector we know the wind platform direction. We know the platform direction where we are going to keep the platform. So prevailing wind direction we can easily find out from the meteorological data. So as far as possible we should avoid keeping our inlet or outlet opposite to the wind direction, or if it is unavoidable then we need to have some cowl so which should protect against the wind pressure. Then the penetration, which I've already covered, so I'm not repeating again what the penetration is. Then next part is the plant room layout is also very essential. As I've already told you that the space constraint is very huge in accommodation platforms. So plant room layout has to be as optimized as possible so that we can keep all our equipment inside and still we can manage well within. Again, we need to cover the space constraint. As I told you, it's the biggest headache and biggest challenge for HVAC. Space what we get is very limited inside the accommodation platform. So we need to very good in space planning. Not only space planning, but we need to take care of the material maintenance requirement also. Because in case of requirement of maintenance, how we are going to handle it. Suppose you have to remove the part and take it out, whether enough space is there to take out to the door. That kind of minute study we have to do with hand in hand with a mechanical discipline which handles the material handling report. Then there is a zone wise area classification. This is a bit detailed and a deep topic, so I won't be covering it now. So let us keep it at the subsequent module. But this is the one of the very important chapter without which you cannot say you are completely an offshore oil and gas professional unless you know the zone area classification, what I mean about it. It is zone 1, zone 2, zone 0 and all. Lot of complex things are there, gas groups are there. So this I will be covering later on. Which equipment to be selected for what and all. This is all classification. I will cover it in the subsequent lectures. Then there are MCTs, that is multi-cable transits. Multi-cable transits are nothing but suppose your cables which are passing through the bulkhead, that is wall, the steel bulkhead. So you cannot simply puncture and take it out in the bulkhead because you need to seal it also. So for that what happens, there is a MCTs comes. The picture of the MCTs, everything I will show it in subsequent lecture. But through a frame and there is only a frame with a lot of holes of the similar dia which we are going to pass and design. So through that all the cables go inside the accommodation, and these are the fireproof arrangement also has been done to the MCTs. So this is what we call as MCTs, and this is also very important factor. And the motor thermistors and the heat tracing. This is also one very important aspect you need to consider while designing the HVAC system for the offshore oil and gas and marine sector. When I say motor thermistors, there are areas or there are zones in the world where oil and gas extraction happens. Say for example in the Norway, Sweden, Russia, where temperature drops down to -35, -20. So in this case what happens, the motor which is at the standby mode, the winding gets completely freezed. So winding should not get completely freeze, and when it should start properly. So to keep it heated basically up to certain level, the motor crankcase should get heated up to certain level for the fan and HU. There is a thermistor being provided for all the motors above 2 kW. That's the standard for as per the NORSOM. So when it is been provided, it keeps the warm, it keeps some warm. And so this particular load also we need to give it to the electrical discipline so they can incorporate in their load list requirement, because they need to provide the DG set for the requirement. And let us talk about the heat tracing. Similarly, you have a drain which is coming out, but as you know, the temperature itself is minus 35, minus 20. So all ice gets formed when the drain happens. So for that, the heat tracing is been done. The heat tracing is nothing but a heating of your drain pipe. It may be in chiller freezer room or it may be normal AHU room. So of course in the winter your AHU won't run. But suppose imagine there is a static water inside the drain. It gets freeze and it may create a block. So in the chiller freezer room, of course, you have a minus 34 degree minus 24 or minus 30 degree irrespective of outdoor conditions. Even being the 40 feet to 50 degrees, still you have to keep it because you have your food inside. So for that also the heat tracing is being done. Now let's move on to the next slide and see what is in the